In this video chapter, I'll show you how to protect finite state machines from being impacted by radiation-induced errors. A state machine has state registers that store information about its present state. These registers determine the state machine's current output and the next state that the state machine will enter when the clock cycles. An SEU can cause an incorrect output, incorrect present and next states. What is worse is that an SEU can flip a bit in the state register, throwing the state machine into a state that was never supposed to happen. An undefined state, in other words. When this happens, the state machine can lock up and cease to function. This can spell disaster if your state machine is part of a critical piece of control logic in the design. For this reason, Synplify Premier can create safe finite state machines that detect and correct errors in the state registers, as well as logic that forces the state machine to resume correct operation. It can do this by performing immediate error detection and correction using Hamming 3 codes, or it can create circuitry that specifies either a forced reset or some custom error recovery scheme. Synplify Premier creates finite state machines that perform both error correction and recovery. Hamming 3 codes are used to automatically detect and correct single-bit errors in the state register, restoring correct operation immediately. Synplify Premier also allows you to designate that you want to create a safe FSM. That is, an FSM that undergoes a forced reset when a single-bit error in the state register is detected. You may also wish to have the state machine undergo other forms of error recovery. This can be done using a safe case FSM, in which the FSM recovers using a custom mechanism. This is done by special settings and by adjusting your RTL to specify a default or an others clause. Here's an example of a safe FSM. That is, an FSM that will return to a reset state upon error. We will first set an attribute in the constraints file, synencoding equals safe, and this will tell Synplify Premier to create a safe FSM. We should also define a reset condition in our RTL. This slide shows the extra reset logic that's created by Synplify Premier when you specify that you want a safe finite state machine. Finite state machine lockup can occur when a state machine enters an undefined state that should technically never occur, but does occur when an SEU causes a bit flip within the state register. To avoid lockup, elect to use the safe case FSM setting in Synplify Premier, available for state machines that trigger on positive clock edges or on negative clock edges. Then include a default or others clause in your state machine RTL. How does this all work? When the undefined state is entered, the state machine recovers in a way that is specified in the default or others clause. The top figure shows an FSM implementation for a 3-state FSM in which we elected not to use a safe case FSM. By instead telling Synplify Premier Synthesis software that we want a safe case FSM implementation of this state machine, we tell it not to optimize away what is supposed to be an undefined state. In this simple example, a 4th state. This is an undefined state that should technically never be entered, but is now not optimized away during the synthesis process. Extra state machine state error detection and mitigation logic is also created, circled in red in the figure. Using a safe case FSM to ensure reliable operation results in a slightly larger, yet much safer design. Synplify Premier Synthesis software takes full care of clock synchronization in safe case state machines, inserting an extra pipeline register between the error detection circuitry and next state logic that it drives. This is particularly important if you're triggering actions off a negative edge clock. You can, however, opt to disable this synchronization capability should the pipeline register inserted cause simulation mismatch problems. Use of the extra register is generally recommended to avoid post-place and route timing violations and clock synchronization concerns. Using a setting in Synplify Premier, you can opt to insert Hamming 3 error detection and correction into your FSM implementation to check and correct single-bit errors in state registers automatically. And here's an example. You can see in the figure how, when you select the Hamming 3 error detection and correction option, additional circuitry is created by Synplify Premier that adds special comparator and parity bit checking circuitry to the design. For more information, or to discuss or evaluate functional safety solutions from Synopsys, visit synopsys.com/fpga-safety. Or feel free to view the additional videos in this series.